So I made a little presentation of what NuNet is doing, and I was trying to also end it with what we spoke last week, that I will try to draft, yeah, let's call it workflow descriptions and service description, then to show what we are doing with them in the NuNet sort of context. So NuNet is yeah, we are providing, basically we want to provide hardware on publicly sourced hardware for running SingularityNET services. So NuNet is this layer between the SingularityNET services and the hardware. That hardware can be, yeah, anything. So we start with a collection of independent and diverse machines or execution environments, and also another collection of independent SingularityNET AI services or executable containers in general, when we go beyond SingularityNET. So in terms of machines, what we want to achieve is that potentially everybody could sort of provide the hardware to the platform, which means that this hardware will be owned, maintained by different entities, either community members, physical, juridical persons, or even clouds, let's say. That means that there will be many types of machines and execution environments. So we are now thinking about PC servers, Raspberry Pis, but eventually it can be cloud virtual machines, mobile phones, Xboxes, robots, and cars, whatever. So this also means that there will be different capacities, of course, of those machines. So we have to take that into account in terms of speed, memory, storage, and then we will also want to take into account that there will be sensors on them, which we may want to use in the computational, let's say, workflows.
Some what? I'm sorry, what did you say? Some? There would be some on it?
Sensors. I mean, suppose there is a robot that we connect to SingularityNET. It will have sensors, actuators, and suppose there is a mobile phone, it will have all kinds of sensors, and we may feed data into the network, not only computing power.
Oh, I see.
So
okay.
What we want to do, we also want to take into account this. I mean, these kind of things are also certain, I mean, it's capabilities of machines, sensors, actuators, things like this.
Right.
Temperature meters, cameras, you name it.
Right. So you want to manage the resources of the machine, resources in the widest possible sense. Basically.
Indeed so. So yeah, there is another aspect that we want to take into account, that we want to take into account certain user preferences. Let's say if I give my mobile phone to a platform, I may not want to use it for certain things. Let's say, I don't know, I may not want the people to access sensors like camera, but I may also may not want to use it for certain computational tasks, for example, financial, because I may think that this is not what my phone is needed for. So, which means we will have to some sort of different user-defined preference on each machine. And all this, we want to connect into this sort of loosely defined network with which will have non-uniform topology, which will also be uncertain, meaning that we will not know it for sure. What is the topology of the network? And it will be, of course, dynamic, since machines will go down and up. And all this information, we want to have machine readable and accessible to the whole network with probably certain permissions. Like not everything should be public. However, it should be accessible to the network. So this is the machine part. Now, with the collection of separate SNET AI services, what we want to have is that we want to be able to sort of serverlessly, I mean, serverless deployment of those containers, meaning that we want to have to be able to deploy these containers on any machines, which is usually called serverless deployment infrastructure. So those SNET AI services also will be owned not only by SingularityNET as they are now, but also by different community members. That could be any person. They will have distinct functionality, of course, which we hope that will be, I mean, first of all, it will be well-defined and expressed inputs and outputs as it is now. then somewhat explicitly defined functionality of those services, which is something that is a huge sort of question mark for me. And at least now we don't have this. Then we'll have explicitly defined resource requirements. Resource requirements for the machines to run those services. Then we will have certain historic performance metrics and reputation scores from reputation agencies. And also it will have to be machine readable and accessible to the network and accessible to machines to a certain level and to other services. So the idea is that, I mean, this is the overall idea that those SNET services should overlap so that to sort of enable all this marketplace and competition between services. And where we want to go is this picture, which means we want to be able to map the services that needed for certain application on the machines that can run them, and then enable the communication between all those services so that the user or application functionality can be enabled by those sort of, let's say, ad hoc assemblage of services on different machines. So yeah, this kind of means that what we are building is that we want to build to enable dynamically construct the application workflow for each application and maybe for each call of a user, depending on how heavy this call is. And on the architecture, well, I call it hardware/software mesh. So and then eventually what this means that we will want kind of many-to-many relationship between machines and services. And to enable to dynamically stitch them together, ability to scale up and down automatically as required for each application, meaning that most probably if we run serious applications that will need more than one machine to run the same service. So we'll have to take care of load balancing of multiple user requests, direct and distribute token flows from users or applications to each AI service utilized on that and each machine, because there will also be a tokenomic system for that. Yes, and this ad hoc sort of network, ad hoc assemblage of services for one application, they may run on different execution environments. Yes, so on top of that, we will want to match soft constraints, which is, let's say, user preferences of what kind of workflows they will allow, and hard constraints, meaning that we will have to match requirements for the computational resources and the abilities of machines to sort of run those services. So. Now, the way we are doing it with NuNet is that we're developing platform. Well, we do this use case-driven development, meaning that we are developing showcase application, and in parallel, which has certain sort of well-defined functionality. But then we're also using that. We are developing platform side, meaning that implement all the components that can be implemented in application agnostic ways, which are general, not related to that application. We implement them in a platform. So we take care that other applications can use them. So in application side, we are building what's called fake news detection. And we recently sort of renamed it into fake news warning. And the idea is that we will have a Chromium extension, which will, when the user activates Chromium extension, it will read the content of a page and notify a user about the probability that this page contains fake news. So that is the basic idea. Well, another idea is that we want this application to be sort of evolving, meaning that it should be possible for community to augment it on the backend side. And the backend consists of a few, right now it consists of a few SingularityNET containers, which are stitched together according to a hard-coded workflow definition. And we are yes, what we're doing, we're just trying to make sure that this workflow works correctly on a platform. And we're going into this load balancing and multiple requests, sending multiple requests. So I think on the left side, this is a general scheme of the application. The above one is just a browser extension, but then browser extension sends a request to the backend, and then everything is sort of stitched together in the backend. If you have any questions, maybe ask right away. Otherwise, I will just go through it.
I think that looks awesome. I didn't know any of that. Yeah.
So the browser is actually, it's still in the development. This is today's kind of mock, not mock, but today's version. Yeah, sorry, you wanted to ask something new?
No, you can go on. I mean, my understanding is that the thing that I find interesting is from the user's perspective, that is basically giving its resources for rent. It's kind of like a form of staking, but more sophisticated. I mean, and probably more with a better return on investment or something. Am I correct?
Well, we are not yet. I mean, there is an economic side to this, but I sort of didn't really explain it here because it's not that relevant for what we're doing. Which means I'm more emphasizing this functionality, which needs to find services on a platform, enable to deploy them somewhere where they will run, and to build all this workflow so that all the calls, sort of this text, I mean, that functionality is done and the browser extension gets the result. And this result is being calculated by different containers. So they have to communicate and it's like functions. Yeah, so I emphasize this.
I mean, on the business side, no, our main focus, NuNet, is working toward a token sale, but that's orthogonal almost to the deeper backend functionality, which is clear why this connects to AI-DSL, right? Because you have processes that need to match with hardware resources, so you got to describe the hardware resources and describe the needs of the various processes. I mean, it's in the medium term, it's tailor-made. I mean, it's a perfect match for AI-DSL, exactly how the two development paths match up in practice in the near term is a different question.
So the reception was very bad, Ben, on my end anyway. I did understand half of what you said.
All right.
That is NuNet. It has its own token. I think I understood that, and it's relevant to the AI-DSL for all the basically real life part where we have to take into account actual resources on top of just not just the algorithm, but where it's running on. And I understood that. I don't know if there was more to understand.
Yes, I think that's right. So, shall I go on?
Yeah, I think you can. Maybe Ben is talking and he doesn't know we can't hear him. I don't know. But yeah, I guess you can go on.
Yes, so on the platform side, basically, so this is what comes closer to AI-DSL. We have workflow definitions which define all this workflow for. I mean, in principle, workflow definitions should describe the application. It's almost like how do you call it? Abstract syntax tree or something like this. So we have workflow definition, Then we have service metadata, which describes each SNet AI service. So something, part of it is probably described in the registry, part of what we need. And then we have machine metadata, which describes each machine, capabilities of each machine, and other metadata that is needed. So we have kind of three descriptions. Then we have workflow aggregation code, which sort of called NuNet orchestrator, which constructs the actually working workflow of this abstract, well, let's say, I mean, the graph of the program from these definitions. And it does by searching and for deployed and available SingularityNET services on a platform, initiates the deployment of required SingularityNET services if they are not yet deployed. And of course, takes care of they are deployed on the right machines. I mean, the machines that can sort of can run them. So receives input from all the parties and aggregates the final output and sends it to the browser extension. So that's basically the workflow. And we do this by putting a sidecar container near on every machine actually, which we call NuNet adapter, which takes care of all the everything that happens in the machine. So deploying containers, SingularityNET containers on that machine, routing data from platform to these containers and back and forth. Also with tokenomics, which we will not. I didn't emphasize it here. So, and SingularityNET services on the machine can communicate only via that adapter and cannot touch anything else on the machine. That's sort of general thing. We didn't go to the security too much, but it's a principle that we try to follow. And yeah, of course, everything is dynamically orchestrated depending on the available hardware. And of course, the price of hardware, that's another part. So this, I drew kind of this workflow construction sequence. I more or less explained it, but the way it works, so we get a request from application side, which means from the browser extension, to certain NuNet orchestrator on certain machine running on the platform. This machine basically asks, and it gets the workflow definition description. So this machine. Then it asks, it requests all the required services. It requests a platform. Are there any services that available to run what these SNet service containers that are described in the workflow description? Then it gets the answers from them with the metadata of those services. If those services are not deployed, then it deploys them on certain machines on the platform. Then it actually, this is a sort of the number 10 is an important part because here what happens, it happens this compilation of the workflow and actual verification whether it will work to whatever level that we can do. There is another thing that I missed here is smart contract signing between all the parties in order to sort of implement this workflow. And then it just sends all the data to all the services that need to do the work, collects the results, checks those results, combines them, and sends back to the browser extension or to the user. So if everything works, this is how it supposedly should happen. So, and here I wrote example definitions of example. So we define all those things in JSON files simply because they are text-based and we can encode them. Yeah, encode them and send them via gRPC between adapters. So the workflow definition, in general, the workflow definition, let me see. This is basically the main part of workflow definition. It defines the graph of the computation, and it defines it in terms of names of the services. So this is more or less real graph of the fake news detection. So we have fake news score container, which actually calculates the final score of probability of content to contain fake news. Then it calls two child services, which are just the services, which actually they calculate what is the relation between the currently used algorithms are quite simple that we use. They just estimate what is the relation between the title of an article and the body text of an article. But they also use some other child containers, and also they use natural language processing model, which is built by the Stanford NLP open source repository. So everything else, well, I will go through this, but this part, in principle, it should be dynamically should be dynamically constructed already, but I just wrote it in order to be a little bit more clear. So when it's constructed, we will have a link to a container of each service that we'll have to run. For now, it's Docker containers, but in general, it may be anything. We'll have declarations of input and output of each service. And then we will have a full sort of expanded tree. Now, I think I will go to the other ones, which hopefully will make the first one more clear. So the service definition. In the service definition, we will have name, which will be, so the name of the service, it may be address of the service, but basically this will be a new unique name using which workflow definition, using which whatever code that will process workflow definition will be able to find the service on the platform. So yeah, this is just an example. But so basically there will be current image of the service. There will be declarations of input, output, functional, whatever function of the service, which I don't know, just don't know how to define now. Now, input and output, right now, what we're using this one. We just encode the protobuf definition of this service into a string, and we pass it around via gRPC calls. It could be also in this type declaration when we will know what to do with it. Then reputation, we can skip this, but this is the idea is that each service will have to be, hopefully there will be a reputation system in a platform which will give reputation scores to each service. And we will want to somehow relate it to that. Now, this is probably the most interesting part, which means that what are the resource requirements to run this service? And we will use this in order to map services to the machines on which they can be deployed. And then price of a service, something that we now have on the SingularityNET services. As a thing, probably now we have a price per call. Yeah, all right. So probably this is what we'll have. Now the question that is also we may want to sort of determine here whether deployment is included in this price or excluded. So who pays for the deployment? And then user-defined constraints. For example, I don't want to run this algorithm on any coal-powered machines, if that's possible even to do.
So by deployment, you mean the machinery that is essentially creating the workflow, not the service itself? I'm not sure I understand.
Well, yes. I mean, the machine that will be creating workflow will take care of this service container, which is so the machine will ask, let's say the platform, for now, the platform, do you have running your UCL and LP service somewhere? And it will say, no, I don't have it running, but actually it exists here, just serverless on the registry of Docker containers. Then the machine will take care that this Docker container will be deployed on certain, this NuNet orchestrator part of the platform will take care that this container running US NLP service gets deployed on certain machine on the platform. And then it will have to check the resource requirements and price and so on and so forth, and to see whether this match. For now, we sort of try most of, the way we go, we sort of take care that these things will have to be sort of dynamically constructed, but we start with static construction. We start with,
Yeah, it makes sense.
Because otherwise we cannot start even to test whether it works. So then the last one is machine metadata example. So let's say we have machine. Okay, these are just technical. Then we have type, let's say, any of them. Then we have resources, which are total resources on the machine. Now, total resources doesn't mean that they're the full machine, because it could be that a user will say, please use half of my machine, but not everything. So these will be somehow user-defined. Most probably the way we will do it, we will write some sort of script which will benchmark a machine. And then a user will be able to sort of tell what percentage they want to give it to NuNet platform. Then most probably we'll have to also declare available resources, because if certain containers will run on that machine, not all the resources will be sort of available for the new containers. However, we use now a HashiCorp's Nomad container orchestration system, so it may take care of this. Then we will have prices of a machine. So how exactly we're going to determine prices, it's a kind of, work in progress, let's say. But for now, we are thinking of CPU usage, RAM usage, time, and network usage. The biggest problem is actually CPU usage, because you cannot really map it nicely to the algorithms, to the computational complexity. So then we have constraints, which will be defined by a user or owner of each machine. Then we would like to have performance metrics, is how available, what is the availability of machine, and certain reputation. We don't want, this availability will have to somehow be determined by the platform and probably written somewhere in the reputation agencies, because we do not want the user himself or herself to determine what is the availability. And of course, also the success rate, which is based on the history. So where will it be encoded into this machine metadata declaration, or whether it will be resolved somehow in a more interesting manner, we'll see in the future. For now, we are just encoding these things to, as I said, to make things work.